All right, so here we have the winner of a raffle will receive a 2-year scholarship to the college of their choice. If 1,000 raffle tickets were sold and you purchased 5 tickets, what are the odds against you winning the scholarship? All right, so we have odds against. Well, first off, what do we have? Well, we have 5 tickets we bought, and that means there's 995 tickets that we didn't buy. So we've bought this many, didn't buy this many. And so odds against are going to be what? Well, we're not going to win any of these. So the probability that we're not going to win is going to be 995 to 1,000. The probability we are going to win is going to be the 5 we bought out of 1,000. And again, multiply by the reciprocal down here, multiply by the reciprocal up here. And so we're going to get basically a 995 to 5. And if we divide that, that's going to be 1, that's going to be 1, and that's going to be a 9. So it's going to be, it looks like 199 to 1. So the odds against are 199 to 1. You're going to not get that scholarship. Now the odds for, so odds in favor are going to be what? Well, we reverse that 1 in 199. Okay, so that way, that's the way it looks one way, and this is the way it looks the other way. All right, so that's kind of how horses are. Now, odds given at a horse race at all games of chance are usually odds against. So that's kind of how to think about it. So the odds in favor of a particular horse winning a race are 2 to 5. Then the odds against are 5 to 2. So again, you're just reversing it. So at a horse race, the odds on this horse are given simply as 5 to 2. These are the house odds. So that's kind of how to think about this. House odds tells a gambler what the payoff is on a bet. For every $2 you bet on the horse, the gambler would win $5 if the horse won, in addition to having that $2 bet returned. Okay, so that's kind of how betting wins. And so, if you're doing a lot of gambling, this would be something that you'd want to kind of know when you're doing that. All right, so let's kind of go with that and say, well, odds enable us to play and bet fairly on games. So, for example, we have seen that the odds in favor of getting $2 when you roll a die are 1 to 5. Suppose this is a gaming situation. You bet $1 on a 2 turning up. So, in terms of your bet, there is one favorable outcome if you get a 2, and 5 unfavorable outcomes, either getting a 1, a 3, a 4, a 5, or a 6. Now, the odds in favor of getting a 2 are 1 to 5. Remember, we're just switching up the 5 and a 1, flip them back and forth. And that compares the number of favorable outcomes, 1, to the number of unfavorable outcomes, which is 5. Now, using the odds in a gaming situation where money is waged, we can determine if the game is fair. If the odds in favor of an event are A to B, so again, if we have like a 1 to 5 or a 5 to 1, the game is fair if a bet of $8 is lost if event E does not occur, but a win of $B as well as returning the bet of $8 is realized if the event E does occur. So, for example, the odds in favor of $2 on a roll of die are 1 to 5. So, if you bet $1 on a 2 turning up and the game is fair, you should win $5 and have your $1 bet returned if the 2 turns up. Now that we know how to convert from probability to odds, let's see how to convert from odds to probability. Okay, so we've gone one way. We know we've gone from the probability. So now let's go the other way. Suppose the odds in favor of an event E occurring are A to B. And again, it doesn't matter what A and it doesn't matter what B are here. This means that the probability of E divided by the probability of not E are A to B. Or probability of E over 1 minus the probability of E are A to B. Now, if we solve the equation over here for probability of E, we obtain the formula for converting from odds to probability. So that's a lot of words, and really what we're looking at is this simple, nice equation. Probability of E is A over A plus B. Now, if the odds in favor of event A are A to B, then the probability is given by this equation. All right, so these are some just kind of odds in favor kind of things. A fatal shark attack are 1 in 280 million, whereas dying from a tobacco-related illness is 1 to 2. So, very, very not likely, and that's much, much more likely. Okay, so and then there's everything kind of in between there that you can see. But what we're going to do is we're going to use this equation, probability of E is equal to A over A plus B, to solve this last equation or last checkpoint here. So it says the odds against a particular horse winning the race are 15 to 1. Find the odds in favor of the horse winning the race and the probability of the horse winning the race. Well, if the odds against are 15 to 1, what are going to be the odds in favor? Well, if this is 15 to 1, then if we switch it around, it's going to be 1 to 15, right? Remember, we could just switch them, and that was how it's going to work from odds against to odds in favor. Now, with it being odds in favor, then this is going to be our A, this is going to be our B, and our probability of the event is going to be what? A over A plus B, which is going to be 1 over 1 plus 15. So that's going to be 1 out of 16. And if we divide that out, depending on if they want it as a decimal or not, sometimes they do, 0.0625. Okay. But again, I would say probably that would be the most exact answer, even though this one does terminate and it does end as a decimal that stops. That would give us either one would be the same, but that's how you would figure it out. So you have to go find odds against, switch that odds against to odds in favor. Once you have odds in favor, then you have your A and B, and we can find the probability of E by taking A over A plus B. All right, so hopefully that will help you get through this section.